There are more bacteria on Earth than there are stars in the observable universe. Just think about that for a moment. That's a mind-boggling thought, isn't it? It's almost impossible to wrap our heads around such vast numbers. These microscopic organisms are everywhere, invisible to the naked eye, yet they outnumber us by an unimaginable degree. They're in the soil, the air, the water, and even in the most extreme environments. And even on our skin. They live on us and within us, playing crucial roles in our health and ecosystems. Now imagine if we could stack all these bacteria one on top of the other. The sheer number is staggering. Would they reach the moon? Could they form a bridge to the stars? Would they even surpass Mount Everest? The tallest peak on Earth would seem small in comparison. It sounds like a ridiculous question, the stuff of late-night pub debates, but it's a question that hints at the sheer scale of the microscopic world, a world that is as vast as it is tiny. We tend to think of ourselves as the dominant life form on Earth, but in terms of sheer numbers, bacteria make us look like a tiny footnote. They are the true tenants of this planet. Their world is hidden from us, visible only through powerful microscopes, but their impact on our planet is undeniable. They shape our world in ways we are only beginning to understand. Mount Everest, the tallest mountain on Earth, stands at a mighty 8,848.86 meters, or 29,031.7 feet, above sea level. It's a colossal peak, a testament to the power of geological forces that have shaped our planet over millions of years. Could bacteria, these tiny organisms, really stack up to such a height? It seems almost unfathomable. It's a question that captures the imagination, forcing us to confront the vastness of the microscopic world and the sheer abundance of life that we often overlook. These microorganisms are everywhere, in every environment. The very act of stacking bacteria to the height of Mount Everest is of course impossible. The logistics alone are mind-boggling. Bacteria don't conveniently arrange themselves in neat little towers. They thrive in a chaotic, bustling world. They exist in a chaotic, bustling world of their own, interacting with their environment in ways we are only beginning to understand. Their interactions are complex and vital, but the image of a bacterial tower reaching towards the heavens is a powerful one. It's a metaphor for the unseen yet immense presence of microbes. It speaks to the incredible scale of the microbial world, a world that exists all around us, largely invisible and yet utterly essential to life as we know it. These tiny beings play crucial roles in ecosystems, health, and even the air we breathe. Before we can even begin to imagine stacking bacteria to the height of Mount Everest, we need to grapple with a fundamental problem. How do you even begin to measure the total number of bacteria on Earth? This is a question that has puzzled scientists for decades. These microorganisms are incredibly small, typically measuring just a few micrometers in length. To put that into perspective, a micrometer is 1/1,000,000th of a meter. So we're talking about organisms that are smaller than the width of a human hair. Imagine trying to count something so minuscule. Counting every single bacterium on Earth is an impossible task. They are everywhere, in every conceivable environment. They exist in such vast numbers, in every nook and cranny of the planet, that any attempt to count them would be like trying to count the grains of sand on a beach. The sheer scale is mind-boggling. Scientists have developed various methods for estimating bacterial populations, but these methods are still subject to significant uncertainty. Despite the challenges, they continue to refine their techniques, hoping to get closer to an accurate count. Section 4. Bacteria towers. Let's assume for a moment that we could magically stack all the bacteria on Earth into a single tower. How high would this tower reach? Well, the answer is, it depends. Bacteria come in a variety of shapes and sizes. Some are spherical, others are rod-shaped, and still others are spiral-shaped. This variation in size makes it difficult to come up with a precise estimate for the height of our bacterial tower. Some bacteria are incredibly small, measuring just a few hundred nanometers in length. A nanometer is 1/1000,000th of a meter, so these bacteria are truly minuscule. Other bacteria, however, can be much larger, some reaching up to a millimeter in length. That's still tiny by our standards, but it's gigantic in the bacterial world. Section 5. A number beyond comprehension.